We will now evaluate the Monaco track stop sign detection performance. So we can do that, restart the terminal and select the local pilot mode. I have to press the record button. Now start recording now. The convolutional model is performing once again very well. Let's see where they detect any stop signs on this road. They detected a stop sign somewhere. We'll evaluate this afterwards. But from what I can determine, as there is a very low image input, and once that the image is scaled in the stop sign detection algorithm, although a bilateral filter is applied to smoothen the uniformly upscaled image, there is not enough data for the car that's detecting the stop sign very well. Okay, and it's still detecting stop signs here. So let's stop this and determine it and see how it performed. Okay, so let's go to the models and then go to data, and the data recorded now is this one. So what we can see is there is a false positive detection, and there are a few, and you can see that the false positive detections are upscaled. So I think there's not enough data for the car to actually determine whether it's a stop sign or not. So there was a few false positive detections. Here in the shade as well were a few false positive detections. This is not that good. There we go. There's another false positive detection. You can see there are a few false positive detections, so the performance of the classification model is not that good. I think also the shades in the trees have quite an abrupt effect on the classifier's detection algorithm. Let's go down to the stop sign. So there are a few false positive detections. Let's move to the array where the stop sign was. Okay, here we go. Here was the stop sign. Okay, so there you can see the stop sign is barely visible, and it's a very small piece of this small image scale. So I think also another solution would be to increase the size of the stop sign itself. So it's still not visible, it's not visible. So the size of the bounding box is approximately the size of the stop sign detection algorithm. So the distance from the car to the stop sign is still large, so the stop sign is small. Let's see if it can detect the stop sign is more visible, but not that much yet. There is visible, but there it detects the stop sign immediately. Let's see, there's another detection, and then it moves back to this false positive detection with another true positive detection, true positive, and then again moves on. So possibly the stop sign is very small. So if we combine a small input image resolution with a small image within that photo, that means that a very small percentage of that pixels or a few data represents the stop sign. Therefore, a larger or higher resolution input image, meaning there's more data, more pixels for the classification problem to accurately detect a stop sign.